So let's go with example 2, graphing rational functions. We already know what we need to do from the last video, but again, we got to figure out what is the y-intercept of this function. Go ahead and factor numerator and denominator so I can figure out if we have any vertical asymptotes or do we have a hole. Then we're going to figure out what the x-intercepts are from that. Then we've got to go through and figure out what are the horizontal or slant. Do I have a horizontal asymptote or do I have a slant asymptote? And again, that's all dependent upon the degrees of the numerator and denominator. And then we got to go through, after we figure that out, okay, well, let's plot some points and find out where I'm supposed to be and then sketch the graph. So with this particular example, why don't we go ahead and figure out what the y-intercept will be right away. So my y-intercept, again, I'm going to go through, and how do I get the y-intercept? Well, I just go through and I substitute 0 in for all my x's. So if I substitute a 0 in, these do not contribute. If I substitute a 0 in, these two do not contribute. And I end up with negative 10 over negative 15, which is a positive 2/3. So let's go ahead and graph, and it would be about, again, not very precise with these tools, but obviously on your own graph paper and everything else, and on a quiz or on a test, you'd be able to be a lot more precise. So now let's go ahead and factor. So I'm going to factor both the numerator, and then I'm going to factor the denominator. So if we go through and factor this, again, first terms in each are x. This tells me our signs are different. Okay, so plus, minus. Now I'm looking for factors of 10 that differ by 3. So that will be 5 and 2. Then we're going to go through and set up the same thing with the denominator. Again, plus or minus because of the fact that I have a negative sign here. Factors of 15 that differ by 2. So that will be a 5 and a 3. All right, so now as I look at this, I see that these two values here, that's actually going to create a hole for us. And the hole is going to be when x is equal to 5, and I have to figure out what the arithmetic's going to be when x is 5, but ignoring these parts now. So if I substitute a 5 into here, I'm going to get 7. If I substitute a 5 into here, I'm going to get 8 in the denominator. So I have then, it's located at the spot 5, 7/8. Right, so now I'm going to go out here and at 5 and then at 7/8. So a little below the 1, I'm going to make an open circle. Now we go through and take a look for a vertical asymptote with what's left here. So I have a vertical asymptote at x equaling negative 3. My x-intercept is going to be what value makes the numerator 0. So then that's going to be negative 2, 0. So let's plot the negative 2, 0, which is there. It's a closed circle. And then I just happen to have down here, I've got my lines just pre-drawn, so it's easy enough for me just to pull them up. All right, so we'll turn this vertical. And then we'll scroll back up and put it where it belongs. So it needs to be at 3. So right there, I'm going to have to extend this line. All right, well, I'm not able to extend it because of what I have, but you get the idea. So there's my dashed line. Now we have to go through and figure out what the horizontal asymptote would be. So if I look at this, I've got that the numerator and denominator are of the same degree. My leading coefficient in both of these is actually 1. So again, just like the last example, we just happen to have it where our horizontal asymptote, because they are the same degree, is located at y equals 1. Again, I'll scroll down here and I'll grab my line that I have created down here. I'll make it a little bigger in this instance so that I can have it go through the whole thing. And I'll drag that up and it's going to be at 1. So just above, if you notice, just above the point that I have, which is at 5, 7, 8. So it's just above this. All right. So now let's get back to the rest of the drawing. So we'll go through and we'll pick some points on either side. Well, I kind of already have enough over here. I know this is going to be bound by these asymptote lines. So I'm going to draw in here This is going to continue this way. It's going to then have a hole, and then it's going to continue past. It's going to be bound by this asymptote line, so I'm not going to cross it, but I'm going to get really close to it. Now, this is not, I'm not expecting that I'm going to have values that are over here, because I don't have a square, meaning that, you know, the numerator and denominator, they're not different by a squared term. So it's not like I have a 1 over x squared where they would both be on the same side. So I'm thinking it's going to be over here. Only one good way at which to go through and figure out if it's going to be over there or not, and that's to go through and figure out an XY table. So let me just choose some values like, well, we'll go with -4, -5, and substitute those in. So if I substitute a -4 in here, I'm going to get -2 divided by -1, so that'll just give me 2. So I am up here then at 2. And then if we substitute a -5 into here, so we're going to go through -5 minus 2, that's going to give me -3. And then -5 plus 3, that's going to give me a -2. So I'm at 3/2, or 1.5, as I'm moving out this way. So then I can see what's going on. This is going to follow a pattern. I can go through and do -6, and I'll notice that if I do -6, I get -4 over -3, which is 4/3. I'm going to get closer and closer and closer to this line. So as we come this way, we're going to continue. And then as we move our way up, this is what our graph is going to look like. Again, with this technology, it's a little wobbly. When you go through to do it on your graph paper or on your regular paper, it'll look much better. Okay, so again, just to recap, we got to make sure that when we notice where there's a hole, we actually have to find that point so we can go ahead and place the hole in the proper location. We've got our asymptote lines that we've drawn in. Notice they're dashed because they are not part of the actual graph. The only thing that's actually part of the graph is the curve here and this curve here with the hole that continues. All right, so if we were going to talk about the end behavior as x approached positive infinity, then we would be saying, okay, well, as x approaches positive infinity, this function approaches 1. As x approaches negative infinity, this function is going to approach +1 from above. If we are approaching -3 from the positive side, then the function approaches negative infinity. If we are approaching -3 from the negative side, then this function is approaching positive infinity. All right, so hopefully this was helpful. This is our second video on dealing with examples of graphing rational functions. Hope this was helpful, and have a great day. Thank you.